Imagine this. You're standing in the middle of the Arctic. The air bites. The wind sounds like broken glass. Nothing grows. Nothing moves. Except you hear it. A low, steady thunder rolling across the white. It isn't a storm. It's a machine, not a car. Not a normal truck. A moving shelter. A lifeline. Out here, vehicles aren't just transport. They're survival suits on wheels. Today you're meeting the giants of ice. Massive expedition trucks built to cross frozen oceans, carry labs on their backs, and keep people alive where a mistake can cost you your life. Some of these you've never seen in your feed. Some almost no one has. And the final one. It's so long you could park a small neighborhood on it. Stick around. Let's start with a modern oddball you might have glimpsed in short clips, the Kamaz Arctic. Picture a huge, long-nosed truck, but it doesn't steer like a normal truck. The front and rear halves hinge in the middle, and the entire body breaks to turn like a giant metal snake. Those balloon-like tires, low-pressure specials that spread the weight, so it floats over snow, muskeg, and sea ice. Kamaz built it in 6x6 and 8x8 versions with an apartment-like module, so a small crew can live, cook, and sleep inside for days while working far from any town. Tests ran in Yakutia, one of the coldest inhabited places on Earth. One configuration weighs around 40 tons when fully loaded and uses a diesel in the 450 HP class, and the turning radius, despite its size, is tight for an Arctic hauler thanks to the articulated frame. The whole idea is simple. If roads don't exist, make your own path gently without breaking the crust. That's why the tires are so wide, and why engineers focused on keeping ground pressure low. You could call it a fortress that tiptoes, but the Arctic doesn't wait for anyone. What if your road is drifting snow and ice hummocks? That question wasn't new. Back in the late 1950s, the US Air Force needed a truck to haul heavy gear, think big missiles and their support equipment, without paved roads. Enter the FWD MM1 Terra Cruiser. Imagine a slab-sided aluminum brute rolling on unbelievable tires, so large you could sit inside the footprint. Those were Goodyear Terra tires, run at very low pressure, and the driver could change the tire pressure from the cab to match soft snow or firmer ground. The MM1's job was specialized: tow huge loads like Matador and Mace tactical missiles, and their trailers over rough ground, sand and snow. It wasn't pretty, but it was tough. And yes, these rigs showed how low-pressure tires could do what tracks sometimes couldn't: move fast, stay simple, and avoid chewing up fragile terrain. A lot of these served in the Cold War years. The Air Force bought well over 100. You can still find a few survivors today. Some converted to work trucks after service. If you ever see one, the tires will stun you before the rest of it does. Now cross the ocean to early 1960s Moscow, where engineers stared at a blank page and asked, what if we build a 6-wheeled snow rover the size of a small bus? The answer was the Zil E167. 2 V8 engines sat in the body, working together for a combined punch of around 360 horsepower. The cab was pressurized and insulated for deep cold. The wheels were enormous, close to 1.8 meters tall with low-pressure tires. The drivetrain sent torque to all 6 wheels. Front and rear axles could steer, and the underbelly was armored smooth, so the truck would slide over snow instead of digging in. On paper, it sounds like sci-fi. In testing, it did the real thing, plowing through meter-deep snow, fording icy water, and crawling over Siberian terrain that turns regular trucks into stranded sculptures. It never went into mass production because complexity and fuel costs were brutal. But the single prototype became a legend, and today it's preserved in Russia as a symbol of that era's wild ambition. You can see the dimensions and those staggering wheels documented. This wasn't just big. It was built like a land ship. You might be thinking, okay, big wheels are cool. But what if wheels just aren't enough? Then you do what the Soviets did in the 1980s. Drop the wheels entirely and go full tracks. Meet the Ural 5920, an articulated tracked transport that bends in the middle to turn. It looks like 2 boxy machines dancing through snow. Because the weight spreads across long, wide tracks, it glides over bogs, deep snow, and thin crusts without punching through. Payload? Several tons even in soft ground with gearing tuned for low-speed, high-torque crawling. These served industry, oil, gas, and remote infrastructure. In places where helicopters were busy, wind could stop flights, and wheeled vehicles sank. If you need to carry cargo to nowhere and nowhere is frozen, this is how you do it. Here's a curveball. Not every Arctic giant is factory-born. Some are built by stubborn dreamers who want to drive to the North Pole. That's the Burlac, an amphibious 6x6 from independent Russian builders. The tires are massive, pressure-adjustable, and so buoyant the truck actually floats. Inside, it's a tiny expedition apartment. Bunks, a stove, insulation, and space for a small team to live for weeks. Power comes from a compact turbo diesel, tuned for torque at low revs. This machine didn't just pose for photos. It ran real polar expeditions across sea ice and open leads, using a prop or paddle effect in the water and the big tires as pontoons. It's the opposite of the old dinosaurs, lighter, simpler, human-scaled, but clever where it counts. If you love scrappy engineering that still respects the Arctic, you'll like the Burlac story. So far you've met monsters with wheels and tracks and a DIY rover that swims. But the Arctic still has an ace to play. Tires the size of living room walls, soft, inflatable, and gentle enough to cross tundra without tearing it up. That's the Rolligon idea. Oilfield logistics teams in Alaska used low-pressure tire fleets for decades. Big rigs sloshing across snow like air mattresses with engines. The concept came from an American inventor, William Albee, after seeing Inuit use inflated sealskins to drag heavy boats over land. Companies like Crowley Maritime built whole operations around these all-terrain machines, running supplies to remote sites while spreading their weight so thin they barely marked the surface. The name Rolligon is actually a tire trademark now owned by NOV, but it became shorthand for the whole category of pillow tire Tundra trucks. And yes, they look surreal, like cartoon trucks. That's part of their charm. If you're enjoying the ride so far, tap like, drop a comment with your favorite so far, and keep watching, because the next machines don't just beat the ice, they try to live on it. Close your eyes for a second and picture the most hostile place you can imagine. Antarctica laughs at that picture. In 1959, engineers in Soviet Ukraine took a tank chassis and turned it into a winterized house on tracks. The name is a mouthful, Kharkovchanka, but it translates loosely to the one from Kharkiv. Think of a rolling cabin with a heavy-duty tracked undercarriage, bunk beds, a kitchen, heating systems, and room for a crew to survive weeks of blizzards. Early versions used a massive V12 diesel. The tracks were wide to spread weight, and the body was insulated to a level only polar travel understands. If the heater quits, nothing else matters. Crews could maintain the engine from inside, so they didn't step into 50-degree C winds just to turn a wrench. These vehicles served at Antarctic stations during the Cold War and beyond, hauling cargo and people, in a place where there's no backup if something fails. Yes, they were loud and cramped, but they kept human beings alive while crossing the coldest desert on Earth. The dimensions tell the story, wider than many city buses, towering on tank-style running gear, and built for grades that would make your stomach flip. Now for a machine that sounds like a myth. Imagine a train with no tracks. In the late 1950s and early 60s, Letourneau designed overland trains for the US military, modular wheeled convoys with power sent electrically to the wheels. The biggest of them, the TC497 Overland Train Mark II, stretched to about 572 feet, roughly 174 meters. That's almost 2 football fields long. Instead of one engine, it used multiple gas turbines feeding generators that powered motors in the wheels, spreading traction across the entire train. Top speed, not fast, around road bike pace. But you don't need speed in a place with no roads. You need persistence. The command cab perched high above the snow, with radios and heated space for the crew. This convoy could snake across raw ice to deliver supplies where planes and ships couldn't always go. It was brilliant and expensive, and as heavy-lift aircraft improved, the need faded. Parts of these giants survive as museum pieces in the north, and when you stand beside a surviving command unit, the wheels alone, 3 meters tall, make your knees wobble. It's a boundary-pushing idea from a time when engineers thought, if rails don't reach, let's take the train off the rails. Speaking of big tracked carriers, Russia continued to refine another giant family, the Vityaz DT series. Picture 2 tracked units joined by a robust hinge. They fold to turn, which keeps traction on both track sets even mid-turn, and they can even climb out of water onto ice shelves. The DT30 variant can carry about 30 tons, while floating and crawling through swampy summer ground or winter snow. Oil and gas crews, rescue teams, and military units use them because they combine low ground pressure with huge payload. Exactly what you need to bring fuel, shelters, drilling gear, or people into regions with no roads and endless obstacles. The DT designs date to the Soviet era and saw service from the 1980s onward, with modernized versions still operating today. If you need to build or maintain anything far north, sooner or later you see that distinctive two-box silhouette on the horizon. Let's circle back to the US side of the story for a second. If you've heard of the Dew Line, the Cold War radar chain strung across Alaska, Canada, and Greenland, you know it ran through thousands of kilometers of nothingness. Building and supporting it needed weird and wonderful logistics. Barges, ski aircraft, sled trains, and yes, low ground pressure vehicles. That's the world where the big tire concept really spread its wings in North America. It wasn't one single truck that built the Dew Line, but a toolbox of machines that could float across tundra without destroying it. The Rolligon tire idea is the bit everyone remembers. Spread the weight, keep the pressure down, protect the surface, keep moving. That DNA shows up again and again in Arctic trucking, for oil field resupply, antenna maintenance, and outpost support. Now, a quick pit stop at a practical workhorse that deserves more love. The foremost Nodwell tracked carriers out of Canada. These aren't glamorous, but if you've seen pipeline photos or telecom towers in the middle of nowhere, a Nodwell probably hauled the crews and poles. With two long tracks and a simple rugged body, a Nodwell 1-10 or 240 can carry a crane, a personnel cabin, or a flat deck with materials. The magic is ground pressure. It's so low that the machine can run on muskeg and snow where your boot prints sink deeper than the tracks. Modern rebuilds add better cabs, heaters, and diesel power, but the concept is unchanged. Go where rubber tires fear to tread and come back tomorrow with more cargo. It's the kind of machine that doesn't make headlines, but builds the things that do. Okay, you've met the workhorses, ready for a legend that didn't quite work, but changed everything. Imagine a rolling research lab longer than a city bus, with a plane on its back. The Antarctic Snow Cruiser, built in the US in 1939, was supposed to be a mobile base for months-long missions. It used a diesel-electric setup, engines driving generators feeding electric motors at the wheels. Decades before that became trendy. Inside it had living quarters, a lab, fuel, and storage. On paper, it could support a small crew across the ice for a season. But when it reached Antarctica, the smooth tires couldn't bite into the snow, and the vehicle struggled to move more than a few miles. It was abandoned, later found in the 1950s under snow, then lost again, likely buried deep or carried off by moving ice. Was it a failure? In the short term, yes. In the long term, it was a spark. Engineers worldwide saw its ambition and asked, how do we make this work? Many of the polar vehicles you've seen since, pressurized cabs, onboard labs, diesel-electric concepts, owe a nod to that wild dream. Before we move on, hit subscribe if Arctic engineering stories are your thing, because the next chapter shows how a strange idea from a honeymoon story and an Inuit trick turned into one of the most important Arctic logistics tools ever made. Let's zoom into those pillow tires again, because they're more than a quirky footnote. The origin story is almost cinematic. An American named William Albee watched Inuit use inflated sealskins to haul boats over land, then wondered, what if we built huge inflatable tires for trucks? He did. The Rolligon concept was born, and although his first company struggled, the technology survived and evolved. The result was fleets of Tundra vehicles in Alaska that could carry fuel, towers, and supplies at walking or jogging speeds across land you'd swear was too soft for anything heavier than a snowshoe. The trick isn't just softness, it's control. Drivers adjust tire pressure from the cab to match conditions. Go softer on boggy ground, firm up slightly on crusted snow. Keep the contact patch huge, so pounds per square inch stay low. This isn't racing, it's floating. With outfits like Crowley Maritime adopting these platforms for the North Slope, Rolligon went from lab curiosity to daily tool. Even today, the trademark belongs to NOV, and the basic principle is still used all over the Arctic. And the Soviets noticed too. They made their own low-pressure tire vehicles, some of them uncanny mirrors of American designs. But while soft tires were ideal for tundra and snow, there were still jobs only tracks could do, like crawling over shattered sea ice or up steep sastrugi in Antarctica. That's where Kharkovchanka earned its myth. The interior wasn't cushy by modern van life standards, but for 1959, it was visionary. Crews lived inside a tracked box warm enough to sleep, cook, and plan traverses. With any other truck, you worked outside to fix things. With Kharkovchanka, you opened a panel, wiped off the soot, and kept your fingers. It was loud. It was hot near the engine, but it let humans work in a land that punishes every mistake. The raw specs, 8.5 meters long, 3.5 wide, around 35 tons, with towing capacity rivaling freight trains on snow, tell the tale. Across the Arctic in Russia, the Vityaz DT-30 family pushed the envelope in another direction, turning while keeping traction. Imagine the vehicle as two sleds tied together with a robotic spine. When you steer, the spine folds, and both track units keep pulling. The result is a long machine that can snake through snowdrifts, climb ledges, and even haul itself out of a river cut onto an ice shelf. Payloads hit 30 tons in some variants, which means a single Vityaz can carry a small mobile camp or a heavy drilling module. That's why you see them in oil fields, military supply columns, and emergency responses where nothing else moves. Modernized versions keep showing up, proving that the core idea, articulation plus wide tracks, was right from the start. Back to wheels for a second, because the Zil E167 deserves one more look. It had something we now take for granted on off-roaders, a central tire inflation system. From the driver's seat, you could tweak pressure to claw through powder or firm up for thin ice. Combine that with steerable front and rear axles and a slick armored belly to surf snow, and you get a snow rover that looks like it escaped from a space movie. When people call it the father of 6S6s, that's not just hype. It set a template for how to make giant wheeled machines work in deep winter, give them flotation, give them torque, and give the driver control over the tire contact patch. And the MM1 Terra Cruiser? Its legacy is everywhere you see low-pressure industrial tires, on cranberry bog trucks in the lower 48, on beach rescue rigs, even on some modern specialty haulers. Sure, the MM1 did a very military job in its day, yanking missile trailers over sand and snow, but its behind-the-scenes influence is huge. It proved that giant soft tires could carry truly heavy loads without shredding the ground. Given the Arctic's strict rules about protecting permafrost and tundra, that matters a lot. Let's not forget the quiet Canadian workhorses again, those Nodwell carriers. Picture a flat deck stacked with pipe and a small crane, trundling across frozen bog. The cab glows orange in the blue hour of an Arctic afternoon. The driver keeps a thermos under the seat. It's not glamorous, but one load at a time, those machines build the backbones. Communication lines, fuel depots, remote microgrids that keep northern communities and industry connected. When people talk about infrastructure, this is what they mean. You might be wondering where the Snow Cruiser is now. The truth adds to its legend. It vanished, either buried under meters of snow or carried off by a breaking ice shelf. Somewhere, a 1930s diesel-electric Antarctic RV sleeps in the dark. If someone ever finds it, imagine the documentaries. But even if it stays lost, it did its job in a strange way, by failing so publicly that it set new lines of inquiry in motion. A failure that teaches is not a failure you forget. Ready for the finale? We're going to stretch your sense of scale. You've seen big. You've seen huge. Now meet ridiculous, the Overland Train. Mark II wasn't just a truck. It was a convoy tied together with electricity, turbines, and audacity. Think modular trailers, each with powered wheels, the whole set moving like a land serpent. When you read the figure, about 572 feet, you do a double take. That's longer than many full-size passenger jets by a lot. Picture it crawling across a white plain at 30 km/h, humming instead of roaring, the command cab peering over snow ridges like the bridge of a ship. If someone proposed it today, you'd say that's a concept art piece. But they built it, and they drove it. Parts still exist in northern museums, reminders that logistics drives invention as much as war does. After all this, you can see a pattern. Arctic trucks aren't just about power. They're about ground pressure, temperature, and autonomy. Can you spread your weight? Can you start at 50 degrees C without shattering? Can you shelter a crew if a storm pins you down for days? Kamaz's articulated Arctic haulers answer with fat tires and a tiny apartment. The MM1 answered with tires the size of bathtubs and an air system to fine-tune pressure. Zil E167 answered with twin engines and snow surfing armor. Ural 5920 answered with tracks and a hinge. Burlac answered with amphibious wheels and a homey interior. Nodwell answered with yes, we'll get it there, one slow, sure trip at a time. Vityaz answered with amphibious articulation and 30-ton payloads. The Snow Cruiser answered with a dream. And the Overland Train answered with pure gleeful scale. Together they're a map of human stubbornness. What made them special wasn't just size, it was purpose. Each was built because someone needed to do something insane in a place that tries to kill you. Build a radar station, pull a drill rig, rescue a cosmonaut, carry a lab across an endless desert of white. Even the failures moved the needle by showing the rest of us what not to do next time. That's how engineering works in the real world. Try, fail, learn, try again. The Arctic is the harsh teacher, who grades on a curve you can't argue with. Where are they now? Some live on in museums and industrial yards. Zil E167's one-off body survives as a story in metal. Overland Train pieces sit in the Yukon for you to look up at and laugh, because your brain can't process an overland convoy that long. Crowley's big tire fleets changed hands, but the low-pressure idea rolls on under other operators. Vityaz machines and Nodwells still work. Kamaz's Arctic rigs keep testing and tweaking, because the far north keeps changing. And the Snow Cruiser, still out there, probably. A frozen ghost you can't visit. Yet, so what does it feel like to drive one? Imagine steering a building. Every sound is heavy. The whine of gears, the muffled thud of tracks over sastrugi, the soft thump of giant tires pressing snow. Your world shrinks to gauges. Coolant temps, fuel, cabin heat, tire pressure. You plan hours ahead. You look for wind lines to find hard crust. You baby the machine because this machine is your shelter. And when you stop at night, the heater tick-tick-ticks you to sleep while the wind claws at the walls. Here's the strange truth. The Arctic makes you humble. These trucks look invincible on camera, but the crews who run them know better. They check seals. They listen to bearings. They carry spares for their spares. They tie down every mug and tool before a move. Respect, not bravado, is how you finish the trip. That's part of why I love these machines. They turn loud engineering into quiet survival. If you've watched this far, you're my kind of person. You like machines that solve impossible problems. Do me a favor. Tell me in the comments which one surprised you most. Was it the Soviet snow rover with 2 engines? The house on tracks that let crews work in shirt sleeves in Antarctica? The home-built Burlac that literally floats? Or the train with no rails? If you could bring one back and upgrade it with today's tech, which would you pick? I'm tempted by the Overland Train. Electric hub motors, modern insulation, satellite comms, but I want to hear your ideas. And if you want more deep dives like this, real history, big builds and the crazy ways humans push into places that want us gone, tap subscribe and ring the bell. We've got more monsters coming. Bigger, smarter, stranger. The ice is waiting. Let's roll narrative perspective used. Second person, conversational. I talk to you directly throughout, guiding you as if you're standing beside the machines or even driving them. This keeps attention high and makes complex facts feel personal and clear. Storytelling devices used, strong opening hook and sensory imagery. Repeated curiosity gaps. What if wheels aren't enough? Tired of cliffhanger transitions. The next one isn't a truck. It's a train with no rails. Comparisons, fortress that tiptoes, ship on the ice, and payoff moments with surprising specs and real-world outcomes. I mix triumphs with failures, Snow Cruiser, to keep tension and show stakes. Best YouTube use case. Aim for 20-24 minutes with fast but steady pacing. 3 to 4 minutes for the hook tools. Kamaz MM1, 6 to 8 minutes for the core legends. Zil E167. Ural 5920, Burlak, Rolligon, Catco. 6-7 minutes for Kharkovchanka, Vityaz and the Overland Train, and 2-3 minutes for the conclusion and call to action. Visual style, crisp archival photos, museum footage, satellite maps for routes, simple specs overlays, slow drone pans over snowfields, and audible rumble engine layers under VO. Keep captions for key numbers and locations, so viewers of all levels can follow. Sources for key facts included above. Kamaz Arctic articulated design, low-pressure tires, Yakutia testing and 40-ton class figures, MM1 Terra Cruiser low-pressure tire system and missile hauling role, Zil E167 dimensions, dual engines, CTIS and testing, Ural 5920, articulated tracked transporter role and era. Burlac amphibious expedition builds, Rolligon concept, Crowley Catco adoption, and NOV trademark. Kharkovchanka specs and Antarctic use. Overland Train Mark II length and museum survivals. Vityaz DT family payload and amphibious articulation.